Hello there. So for today we will look into subtopic 8.3 involving rotational dynamics. Okay. So for this part today we will look into problem solving involving torque. Okay. So if you look back at the equation, okay, net torque will be equivalent to moment of inertia times angular acceleration, okay, which will be analogous to force, where net force will be equivalent to mass times linear acceleration. Okay, so this equation we will apply over here. So let us discuss one example first. Okay, example 8.3.2. So over here you have force F1 5.6 Newton and F2 10.3 Newton applied tangentially toward this radius given as 30 cm and the mass is given as 5 kg. Okay, it is shown in figure 8.3.4. Over here they wanted to calculate the net torque on the disk and then the magnitude of the angular acceleration. Okay, whereas the equation for the moment of inertia is given below. Okay, so to determine the answer, first we can derive the information given, radius given, and mass is given. Okay, so to determine the net torque, what we need to do is that we need to calculate the total torque acting. So since we have two forces, F1 and F2, that means you will have two torque acting. Okay, so F1 it will produce rotation in clockwise direction. Okay, clockwise direction, that means you will have negative torque. Okay, and then F2 it will produce rotation in anti-clockwise direction, that means you will have positive torque. Okay, so calculating total value you will end up with 1.41 Newton meter. Okay, and then for the second part B, okay, they wanted to calculate the angular acceleration. Okay, since we have already determined total torque from question A, so you can replace that at B over here. And then for the moment of inertia, the equation is already given at the question. So just replace in, okay, and then replace the value and then do the calculation to determine the angular acceleration. So final value you should get 6.27 radian per second square. Okay, next example we have example 8.33. Okay, over here you have a wheel of radius 0.2 meter mounted on a frictionless horizontal axis. Okay, the moment of inertia of the wheel about the axis is given as 0.05 kilogram meter square, and you have a light string wrapped around the wheel is attached to a 2 kg block that slides on a horizontal frictionless surface. A horizontal force of magnitude P 3 Newton is applied to the block as shown in figure. Okay, and then the assumption over here is that assume the string does not slip on the wheel. Okay, so first question what they wanted to do is that sketch the free body diagram of the wheel and the block, and then for question B they wanted to calculate the magnitude of the angular acceleration of the wheel. Okay, so for the first part, okay, these are all the information given, so we can use it to draw a free body diagram. Okay, so for wheel, okay, since the tension will be acting toward the right, that means the wheel will have a rotation in clockwise direction. Okay, and then it has a mass. Okay, so the mass will produce weight, and then the weight will be always acting at the center of an object. Okay, which will be at the center of the circle. Okay, so we have a weight over here. Okay, tension toward your right. Okay, and then since it is at a fixed point, that means you will have a reaction force. Okay, so this reaction force will be able to counter the weight and tension. Okay, so basically it should be acting in the opposite to tension and also opposite to weight. Okay, So therefore the resultant will have a certain amount of angle. Okay, and then for the block, okay, sitting on a surface, okay, direction of acceleration moving toward the right. So we have weight, okay, so once we have weight, we must have a normal force acting in opposite direction, okay, P acting toward the right, and then you will have tension toward the left. Okay, so based on the information and also based on the free body diagram, what we can do is that we can form an equation. Okay, so for the wheel will be rotating, so therefore net torque will be equivalent to I times angular acceleration. Okay, and then net torque will be equivalent to R times T. Okay, and then rearrange in terms of T, which will be equivalent to I times angular acceleration over R. Okay, we end up with equation 1. And then for the block, okay, so net force will be equivalent to ma since the block is moving with acceleration of a. Okay, so therefore net force will be equivalent to P minus T. We follow the direction of acceleration, P positive, T will be negative, which will be equivalent to ma. Okay, we end up with equation 2. Okay, and then what we do is that substitute equation 1 into 2. So therefore you expand the value of T. Okay, and then since we are going to calculate the angular acceleration, so over here a is in linear, so what you can do is that make it as angular, where a will be equivalent to r times angular acceleration. So replace in. Okay, so once we have the equation, we can substitute the value. Okay, and then the unknown will be the angular acceleration. So we solve it for value of angular acceleration, and then we will end up with 4.62 radian per second square. Okay, that is all for 8.33. So for the final question, we have example 8.3.4. Okay, this one you have an object, okay, mass given 1.5 kg suspended from a rough pulley, radius given 20 cm by a light string, okay, as shown in figure 8.3.6. Okay, the pulley has a moment of inertia 0.02 kilogram meter square about the axis of the pulley, and then the object is released from rest and the pulley rotates without encountering frictional force. Assume that the string does not slip on the pulley after 0.3 second. Okay, after 0.3 second, they wanted to determine the linear acceleration of the object, angular acceleration of the pulley, tension in the string, the linear velocity of the object, and also the distance traveled. Okay, so over here they have given the value of constant g, which is equivalent to 9.81 meter per second square. Okay, so for the solution, so as usual, first thing what we need to do is that we draw a free body diagram. Okay, so over here we have two body, okay, which will be the pulley. So for the pulley, direction of rotation, okay, and then weight acting downward, okay, and then you will have a reaction force and also tension. So the reaction force will be from the center of the point of contact, okay, and then tension will be at the side, and net torque will be equivalent to moment of inertia times angular acceleration. Okay, so therefore if we expand RT equivalent to I times angular acceleration, and then angular acceleration will be equivalent to linear acceleration over radius. Okay, so since we are going to determine the linear acceleration first, so we do it in linear acceleration form first. Okay, so replace in. Okay, and then therefore rearrange T will be equivalent to I times A over R square. We end up with equation 1. Okay, and then for the block, okay, acceleration moving downward, okay, you will have weight acting downward, which will be equivalent to mg, and tension acting upward. Okay, since the net force, the block is moving, so net force will be equivalent to ma. So follow the direction of acceleration, so that means weight minus t, mg minus t will be equivalent to ma. So we will end up with equation 2. Okay. Okay, so for the solution of the linear acceleration, okay, what we can do is substitute equation 1 into equation 2. Okay, by substituting, we will end up with this. Okay, then since we have all the information except for linear acceleration, replace in all the value, determine the value of the linear acceleration, which will end up with 7.36 meter per second square. Okay, and then part B, angular acceleration. What we can do is that we can straight away convert linear into angular acceleration. Okay, so therefore by using the relationship A is equivalent to R times alpha. Okay, so linear we have, radius we have, determine the value of the angular acceleration. So we will end up with 36.8 radian per second square. Okay, and then for question C, tension. Okay, so for the tension, we can refer back to equation 1. Okay, so I times A, acceleration over R square. So since we have all the value, just replace in, and then we will end up with tension equivalent to 3.68 Newton. Okay, and then for the linear velocity. Okay, so this one we need to refer to the equation of the linear motion. Okay, by applying equation of linear motion, okay, let's say we use equation V equivalent to U plus AT. So if the object start from a rest, okay, t is given as 0.3 second, find the final velocity. Okay, 2.21. So the direction will be downward, okay, over here. And then the distance traveled, okay, also we use the equation of the linear motion, okay, ut plus 1 over 2 at square. So since u is 0, so we will end up with half at square only. Okay, so solve this, we will end up with the final answer 0.331 meter. Okay, so that's all for this subtopic. Have a nice day.